today we're going to talk about Vertex, and we've already heard several times that it is roughly the equivalent of Node for the JVM, and I just realized that I haven't started my slides, so there they are. So here are my details. I'll also have those at the end. I uploaded this deck to SlideShare this morning, but it's been still processing for the last 4 hours, so eventually it will be out there. So before we get into Vertex and Node, I always like to start with, what problem is that we're trying to solve. And actually I want to look at two. So everyone familiar with the C10K problem? Yes, no, maybe. How do we deal with 10,000 concurrent connections without the server falling down and going boom? Of course, this has become especially pertinent in the last 5 years or so with the birth of our smart mobile devices. And so very recently we actually passed the point where there are now more mobile devices connected to the internet than there are PCs. And this problem isn't going away, so we have to start building application architectures that can handle that kind of concurrent load. And the other problem, most of us are familiar with this as well, how do we build advanced server push features into apps? How do we get data into the browser without having to constantly poll? So we can build, these quote-unquote, rich internet applications, a term that's been, beaten to death considerably. And so these were the types of questions that Ryan Dahl was attempting to deal with in 2008. 2008 doesn't seem that long ago, but let's go back. In 2008, our existing frameworks, platforms, very tightly coupled to this idea that, server's something that receives a request and it spins up a thread to deal with it, and then it sends back a response. And all of this, of course, happens sequentially. Well, of course, this was not web scale. Now, to be able to push events to the browser, the platform needs to be able to handle a lot of open connections that are mostly idle. Now, Ryan's background in systems programming led him to create, a small test environment that could handle thousands of idle connections, and he did this using non-blocking Unix sockets in C. But Ryan didn't want to work in C. He wanted a higher level language. He wanted a higher level of abstraction. In fact, he wanted a dynamic language, and I tend to agree with him. I don't want to work at that low of a level either. As it turns out, life is entirely too short for Malloc. So about that same time, what did we get? Doug Crockford published JavaScript: The Good Parts, and we started taking JavaScript more seriously. It's not going anywhere. It's the most, really the only ubiquitous programming platform that we have for the web. And Crockford showed us, we can leverage the good parts of JavaScript while avoiding the ugly parts that get us into trouble. Then add further fuel to that fire was Google releasing Chrome and the V8 JavaScript engine. And so the first time, not only did we have, a real technology competition going on in the JavaScript space, we had JavaScript going blazingly fast. And now we start the arms race of browsers all over again. And we have more players in the field. We have Google and Apple and Mozilla and Microsoft all trying to outperform one another when it comes to JavaScript engines. So you could bring these three things together, and Ryan has this epiphany. He's like, why don't we do non-blocking sockets in JavaScript? And a few months later, out popped Node. Now, as you say, you've covered Node. None of you came to the Node meeting, it looks like. So who's familiar with Node? Who's written serious code in Node at all? So a couple of us. So you can probably talk about Node a lot better than I can. I can't go in depth with Node because I only learned enough Node to make a reasonable, useful comparison with Vertex. Now, from what I've learned, I like it. It's a solid piece of technology. You use it intelligently, you can build some very solid app architectures with it. But Node does have some shortcomings. So we talked about JavaScript in a positive light a second ago. Let's talk about it in a negative light. JavaScript has its problems. We'll talk about some of those. Node does not really have a good story around vertical scaling. Horizontal scaling, great. Vertical scaling, hard. Inter-process communication, also something that we can do, but it requires a lot of low-level programming, a lot of glue code, a lot of bolting on of add-ons. And then there's this event loop thing. The event loop's great, unless you need to do work that doesn't fit on an event loop, and that's a problem that we can't really solve. So all of these solutions that we have on the node, they require a lot of legwork on our part, and what Vertex does is to take the same event-driven, non-blocking I/O programming model that we got from Node, all the good stuff, and then directly address all of those shortcomings so that you can spend your time working on your app and push all of these concerns down into the framework. So what I want to do is I want to walk through each of the problems, and I want to show how Vertex addresses those. Now, you said you wanted me to ask questions for the giveaway, so I've already decided how I'm going to do that. So pay attention to the slides. I'm not going to say probably any of the answers to the questions, but they will be there. So JavaScript. If you're going to write Node programs, you have to use JavaScript. Now, yes, we can write CoffeeScript and we can write ClojureScript, but the burden is on the developer of the language to get his or her code compiled down to JavaScript, and then and only then does Node pick up with it. Now, JavaScript has some problems. Who's seen WAT? Okay, you guys have homework. You should go watch this. If we had time, I'd play it. So JavaScript does a lot of weird implicit conversions. We have still not a reasonably consistent way to do namespacing and organize large code bases in JavaScript. Now, the Google Closure tools have gone a long way to help us with that, but at the end of the day, there's still very little agreement on how do we structure really large JavaScript code bases. Of course, we have this weird class-like syntax coupled with decidedly not class-based inheritance. It's prototypal-based. And of course, it's just easy to do really bad things. Of course, these aren't the only problems we have with JavaScript, but there's some of them. So Vertex's approach is polyglot programming. Use the right tool for the job. Now, I've been talking about polyglot programming for a long time. Most of you are polyglot programmers. You just don't consider yourself to be. Even if you use one core language, if you're doing web development, you're using several languages. You know, if you consider HTML, CSS languages, you throw JavaScript in there, you throw in SQL or a query language from your SQL persistence library, you're doing polyglot programming. So Vertex takes the approach of bringing in polyglot programming for the core language, programming whatever language you want. In fact, feel free to mix and match multiple languages, and Vertex will take care of the communication between those. So several languages have first-class support today. Let's do a Hello World tour of the languages that are out there. So here's how we do Hello World in Java. So what we're doing is extending a vertical class. I'm going to talk about what a vertical is a little bit later, but suffice to say, this is the unit of programming in Vertex, and we're going to be compelled to implement the start method. So in the start method, what are we doing? We're doing the stereotypical Node.js Hello World example. We're spinning up an HTTP server, we're providing it with a request handler, and all that request handler is going to do is write out Hello World to the response, and we're listening on port 8080. So this is what it looks like in Java. Now the code gets a lot smaller in all of the other languages. In Groovy, this is what we have, doing exactly the same thing. Now notice that we're moving between languages, but the API is consistent between them. If you can expect a method in Java, you can expect it in Groovy, you can expect it in Ruby. Now Ruby is leveraging JRuby under the hood to run on top of Vertex in the JVM, but again, essentially we have the same programming model with Ruby syntax and Ruby constructs. We can also do this in Python, again, same constructs. And of course, if you're a Node programmer wanting to jump onto the JVM, you can write JavaScript. And the JavaScript code that you start to write in Vertex looks very familiar, very comfortable in terms of what you're used to writing when you're doing Node code. And of course, we also have first-class CoffeeScript support that's been added fairly recently. CoffeeScript and Python are the newest kids on the block. Now, in the future, we have some fledgling Scala support that's that's become available. It's not really first class yet. A couple of us are starting to have conversations about adding closure support to Vertex. Theoretically, any language that will run on the JVM, or any language that will compile down to a supported language. So maybe we could take the closure script to JavaScript to Vertex route as well. These are different things that we can do. So now that we've examined the language issue, let's take a look at the second problem. Vertical scaling. So Node.js instances are inherently single-threaded. Why? Because V8 itself is inherently single-threaded from the perspective of the programmer. Now, there are ways around that, but they involve low-level hacking. And as I was telling some folks earlier, in order for me to solve my problems, I don't want to go lower down the stack. I want to go further up the stack. I want to work at higher-level abstractions, not lower-level abstractions. And so anything that the platform can give me to allow me to stay up here thinking about my application and not be down in the weeds, this is something that I'm interested in. And so the implication here is if I'm writing Node programs, my code is going to use at most one core on my server. Of course, the Node.js folks recognized this and added the capability to fork child processes. And to support load balancing across those processes, they created the cluster module. Now, the cluster module, depending on who you talk to, is a good thing or a bad thing. If you look at the official documentation, it's still considered experimental, but there are no shortage of Stack Overflow questions saying, yeah, just use cluster, everything will be okay. Well, let's go that route. So there's a book, actually a few books now on Node. One of the earliest books was called Node Up and Running. It was one of the shortcut style books from O'Reilly. And get into chapter 3, they start showing this example of how to use cluster to distribute the work of Hello World across several Node.js processes. And so this is kind of the minimum viable code that you would need to write in order to vertically scale Hello World on Node.js using cluster. Now, who's doing the work here? You are. There's an API there that you can leverage, but at the end of the day, using that API correctly, the burden is upon you to make this code work properly and to get all of the glue in the right places to make things happen. Now, obviously, this is Hello World. It gets a lot more complicated than this. And if you continue to read the next 4 pages of the book, the code gets much more complex very quickly as they add additional monitoring and management features to a, again, Hello World app. So what we end up with, if we're not extremely careful, is a ton of glue code intermingled with our application functionality. Now, who likes that? No, I like to have my application functionality. I like to be able to look at my domain concepts, see them clearly expressed, and then all of the ancillary concerns, the cross-cutting concerns, I want those pushed down into the framework of the platform that I'm programming with. So Vertex leverages the built-in mature threading capabilities of the JVM to make vertical scaling trivial. So again, meet the vertical. Where did vertical come from? Think atomic particle except for vertex. That's where the name came from. We have some interesting ways of naming things. Not to be confused with vertical as in vertical scaling up and so we've got some terms that are going to be confusing here for a little bit. So vertical unit of deployment. So any Vertex instance, any Vertex application is going to be composed of one or more of these verticals. Verticals, nothing more than the Java classes that we looked at or scripts that we looked at in the Hello World section. So if you write these, you're going to be writing verticals. So a Vertex instance is a JVM process that is running the Vertex engine, if you will. Vertex engine consists of several threads. So we're concerned here primarily with a group of threads that provide us with event loops. So again, we're starting to see one of the first differences. Node, one event loop. Vertex, many event loops. How many? Well, it checks to see how many processor cores you have available using runtime.available processors, and it's going to create an event loop thread for each one of those. And then verticals are assigned to an event loop thread. If I run Vertex with the command line argument instances and I give it a value equal to the number of cores, you're going to see the vertical automatically scaled out to 1 instance per core. Of course, we can run more instances than we have cores, because each instance is typically not going to be able to keep the core busy all by itself. Now, what does this bring up? We don't like to talk about this word. Yeah, concurrency. We've got multiple threads in play, so how does Vertex deal with concurrency? We don't have to think about concurrency when we're in the JavaScript world, because we just have a single thread. So now all of a sudden all these problems get dumped in our lap. Well, hold on. So as we said, each vertical instance is assigned a thread/event loop. You can kind of think of them the same way. That vertical instance is guaranteed to always execute on its assigned thread. It will never execute on any other thread. So once it gets that thread assignment, it's always running there, never anywhere else. Now, a thread may execute multiple verticals, but the same vertical instance will never have its work done by another thread. Furthermore, the class loaders for the verticals are isolated, and that prevents them from sharing global state with static members, global variables, and other things. So all of these constraints give us the ability to write all of our code, and I should have been going through points here, to write all of our code assuming single threading. You know, there's no need to worry about synchronization. There's no need to worry about locking. Of course, now that we've guaranteed that our verticals are isolated, we have a problem. We've got a bunch of processes out there running that are isolated. They can't talk to each other. We can't get any useful work done. So nodes faced with the same problem. So now we actually have 2 problems to consider. How do we get Node.js processes to communicate with each other? Because we know we can fork them, we know we can cluster them. How do we get them to talk? How do we get Vertex verticals to communicate with each other? Because it looks like we've created this walled garden where every single vertical is unable to communicate with another. Well, in the Node.js world, you spend some time Googling about, searching, and you run into a lot of solutions, some of which make me scratch my head, some of which seem okay, but maybe not so much. So one of the first things that comes up is, well, you just need to learn socket programming. You need to start learning using TCP, UDP, Unix sockets, and this is how you get your processes to communicate. Now, what did we just get done talking about? We don't want to be down there. We want to be up here at a higher level of abstraction so that we can focus on our app and not focus on this low-level stuff. Also, Redis pub sub. Okay, that makes a little bit more sense. So I need to figure out how to, of course there's options out there that make it easy to talk to Redis, but I need to learn that. Maybe I don't know Redis. I need to bring that into my app and get that done. 0MQ, this helps a little bit. We're still dealing with sockets, but we're dealing with a higher level of abstraction over plain sockets, so that's getting better. Some other solutions just say, oh, well, there's some built-in messaging and cluster that you can use. Not very full-featured. You can use process signaling, again, down in the weeds. And there are also various eventing frameworks out there that transcend processes that we can work with. The one that seems to be the most popular is called Hook.io. It's dead. From what I could tell, there was some interesting political play that went on there, but if you try to go to any pages other than the legacy mailing list for it, you can't find anything. And there's others like JS Signals and Bean, and these look okay. You can do shared memory with Memcache. That's also an option. What do all of these things have in common? Well, they all require me to hook into some third-party technology that you may or may not want to add to your stack, or they require a great deal of low-level programming, something that I've also said I don't want to do. So, 2 solutions that Vertex provides us. The first is the event bus. The event bus is what we like to call the nervous system of Vertex. It is a cross-cutting abstraction that's built on the platform. So it's built in. You don't have to go get anything to install it. It's not an add-on. It's part of the core. It allows us to send and receive transient messages throughout the application. Not persistent messages. If you want them to be persistent, you need to hook into more of a persistent work queue manager. That we do have some add-ons that are starting to grow up within the add-on module community, but this is not available. So transient messages. If your app dies, your messages are gone. Let's assume it's up. This allows the verticals to communicate with each other irrespective of what language they're written in, whether or not they're in the same Vertex instance. Maybe they're in different instances. And it even allows client-side JavaScript running in the browser to communicate on the same bus. More on that later. So messages are sent on the event bus to an address. Vertex doesn't bother with any fancy schemes for addresses. Simply a string. Any string's valid. It is wise to use some kind of a namespacing scheme to keep things organized. So, something like messages.inbound.a, something that makes sense to you to kind of keep things making sense as the application grows. So a handler is what? A thing that receives messages from the bus. Now, we have handlers in Vertex for just standard programming, such, we have HTTP request handlers, we have TCP request handlers, but we also have handlers that are specifically involved in working with the event bus. So you register a handler at an address. This handler can be in any vertical or any instance of a vertical. So we could be running multiple Vertex instances on the same box. More likely we would run multiple Vertex instances on multiple boxes. And then we can use Hazelcast to work with these. I'm sorry, can you say the last part one more time? So the question is, how do we coordinate the communication across Vertex instances on different machines? How do we get them on the same event bus? I'm actually going to bring that up a little bit later, but I'll go ahead and say it now. There is a cluster mode that is built into Vertex. It's actually leveraging Hazelcast to cluster the JVM instances. And that right now, that's restricted to the event bus, but we'll see some more features coming out around that as Vertex continues to move forward. Other things about handlers. We can have multiple handlers registered at a single address. So I can have multiple pieces of code that are interested in receiving messages that are directed to a particular address. I can also have a single handler registered at multiple addresses. And so I can have one address that I can have a single handler that knows how to deal with different types of messages that are coming to different locations. How do I register a handler? So we're going to do most of the examples in Java code. So here basically we're going to get the event bus object from the Vertex object. Vertex object is available to you whenever you extend vertical. And then we have a handler interface. We're going to implement an anonymous handler here. And basically all it's going to do is print out a message based on the message body. And then we register that handler at the address. It's as simple as that. Now, we support multiple styles of messaging in Vertex. So, of course, we have pub/sub. Deliver a single message to all handlers registered at an address. That makes sense. How do we do that? Well, it makes sense. We have a publish method that takes an address and takes a message and sends it to that address, and then all of the handlers that are registered there will receive it. We also have point-to-point messaging. With point-to-point, it's going to deliver to at most one handler that's registered at an address. It uses non-strict round-robin load balancing. And optionally, you can specify a reply handler. You have a reply handler, that reply handler can have its own reply handler, and you can have sort of a two-way communication process going on between message handlers. So when we do P2P, we're going to do it with the send method. Yes? Mm-hmm. So you just did something very naughty. So the question was, how do you, if you're dealing with round robin, you've got one processor over here that's involved in a long-running job, and so we want to notice that load and not send the request that direction. Well, again, you think load a long-running job, you think blocking work. When you think blocking work, you think, no, this can't run on the event bus or the event. Again, but you don't want to do that on an event loop. That's one of the problems with Node, and has been a discussion that we've had for a very long time in the community, as I've observed, is that when we're doing things on an event loop, what happens when you block for a long period of time processing something on the event loop? The app stops. Nobody else can get requests. Now, Vertex deals with this. I'm not going to deal with it in this section, but if you hold on a few minutes, we'll actually get to that specific solution, because this is a big problem that Vertex attempts to address. Okay, so we're doing point-to-point messaging. We can just do a send, we can do a fire and forget, but we can also do a request-reply model. So the way we do that, I've got the sender and the receiver code here. So the sender, and my slide here is very small, so I'm going to look up here to read it to you. So our send method, we have an address, we have a message. And we're going to add to the last argument here a handler. That handler is specifically there for a reply handler. So we have some methods do not take a handler. They just send, they give the message, and it's gone. Here we're going to expect a reply. The receiver is going to handle the message, and then on the message object itself, it has a reply method where it can send a reply. That reply will go back to the original sender and will be handled by that reply handler that we see in the top section of code. Now that one could also reply, and we could have two-way communication going back and forth as much as we desired. Now this is one part of the API that differs a little bit from language to language, and we'll see an example of that when we get into some JavaScript code towards the end. But for the most part, even if the API, in terms of the mechanics of using it, if they differ a little bit, the concepts are, for the most part, all present. So message types, what kind of stuff can we send around? Well, we can send around strings, primitives, box primitives, booleans. We can also send around JSON objects. In fact, JSON is one of the preferred communication mechanisms for Vertex. Reason why, almost all of the languages that we work in, with the exception of Java, have very nice, very easy semantics for dealing with JSON data. With Java, we actually have this JSON object that we work with specifically for Vertex. Is there a question in the back? Okay. And then we also have buffers, and I'll touch on buffers a little bit later on. So again, we said we can distribute Vertex. So here we have, again, 3 instances of Vertex, all running several verticals, and we have a single event bus that spans all of them. And we deal with that using Hazelcast. So I'm not going to go through the API for that right now. It's really not an API. There's just some command line arguments that we're going to pass, and also some configuration files that we could edit and basically set up our clustering, where one node becomes the kind of the orchestrator of the cluster, and the other nodes, for the most part, become slaves. But all of that is configuration, runs under the hood. When you're in your code, writing your code, you don't have to think about whether my vertical is running on this node versus this node versus this node. All of that stuff essentially just works. I think you had a question in the back. What are we using for JSON support in the Java code specifically? So Vertex. So Tim, when he implemented Vertex, he implemented his own set of JSON object support. And then the other languages, for the most part, we're just using the built-in support for JSON. Yes. Yes. So the question is ultimately, what are we using as the underlying communication mechanism? Almost all of the communication is being done through NIO2, which, of course, means that we require Java 7 for Vertex. So if you're not running Java 7, you're not running Vertex. Do I have to have a configuration file for Vertex in general or for the clustering? Yes, there is a cluster config file, and if we have some time at the end, I can pull it up. It's not very fancy or exciting. It's just configuration for Hazelcast. So something that's somewhat unique to Vertex is that we can also, using the same programming model, we can go into the browser. And so using sock.js, Vertex implements what's called an event bus bridge that allows you to have code running on the server interacting with code running within the browser using the same event bus programming model. So what might this look like? So on the server side here, we're creating an HTTP server, and we're setting up a basic request handler that's just going to serve up two files, an index.html file, and then the very important vertex bus.js. So if in your app you want to write code that uses the event bus in the browser, you will have to include this. You also have to include sock.js in your application. And then we're going to create a sock.js server, so Vertex has a full implementation of the sock.js API. We're going to create that server, and then we're going to create a bridge, and we're configuring the bridge here. And what we've done is we've told it three things. What prefix do I want you to send requests to? And so when I go try to communicate with the event bus, I'm going to be making HTTP requests to /event bus. And then I'm also dealing with another problem. I've got this sock.js bridge out there now, so theoretically any browser that can hit my URL can send messages into my system. That's bad. And this is still bad because what we've done, we've got two arguments here. One says, what types of incoming connections am I going to allow? What types of outgoing connections am I going to allow? And here I've given it a blank array with a single blank object in it that says, allow everything. This is a demo. Listening on 8080. So, client code, what does that look like? So in the client side, we've got our sock.js, we've got our Vertex bus. We're going to get a handle to the Vertex event bus, again through the Vertex object. Look, it looks exactly like the server-side code. And then we're going to say on open, so we have some events that we can listen for. On open means, okay, the event bus is initialized and ready. I want you to register a handler. And basically what I want you to do is echo back any message that I receive. So now let's talk about another way of communicating or sharing information between processes, and that's shared immutable state. Now, why do I have Rich Hickey up here? Because Rich Hickey's all about immutability and values. And so I thought he was a good person to carry this forward. So what if we wanted to manage an in-memory web cache? Could we do that with message passing in the event bus? Well, we want the app to scale across all available cores. Modeling this using message passing is problematic. At one end of the scale, you could have a single vertical that manages the cache. But that means that all requests to the cache are going to have to be serialized through a single threaded instance, and we've lost our vertical scalability that we wanted. Now we can improve that by having multiple instances of the vertical managing different parts of the cache, but that starts to get very ugly and complicated really quickly. So we really don't want to do this with message passing. It's not a good fit for the problem. Now, we said shared state is dangerous, and we prevent a lot of shared state in Vertex out of the box to make it easy to assume a single-threaded programming model. But as it turns out, shared state is only dangerous if it's mutable. In fact, go back to Effective Java, the book that's been around since we've been doing Java programming for the most part. It tells us that if a data is immutable, it can be shared freely. And in fact, such sharing is encouraged. And we want to make that easy to do. And so Vertex actually has a shared data object that is part of the platform that allows us to work with a couple of different shared data stores. First of all, we have a collection of Java util concurrent maps. And so I can create a map out there. It's a concurrent map, supports atomic updates, and I can put immutable data into that map, and that map will be visible to all of my Vertex instances. I'm sorry, all of my verticals. I need to speak correctly. We also manage a collection of Java util sets. As it turns out, these sets are also backed by a concurrent map. So the same underlying infrastructure going on there. Elements need to be immutable values. Sort of. We'll get into that. And currently, this is only available within a Vertex instance, so a single JVM process. Right now, if I have a cluster, I cannot share data across multiple clusters, across multiple instances within a cluster. This is planned. Hazelcast supports this type of stuff, and so it's just a matter of it actually being implemented and tested and put into a release. Question?
Yeah, the elements in the map, the values are objects. Can it call read-only functions also that don't share state? I don't know how this multiple crossover thing works.
Yeah, so the question, I think the question is, if I've got objects out there that are immutable, that I've created, but then I've got isolated class loading, how does that work?
Yeah, can it call a function that maybe takes 2 or 3 of the immutable elements and turns them into a composed result of like a concatenation?
So basically what we're going to have to do to make this happen is cheat. So what are allowed? What can we put in here? Actually, if you drill down into the source code, both of these data structures employ a type checker, and they look at what's being pushed into the map or the set to ensure that it's a type that the concurrency model would actually support. So we can put strings in there. Obviously, they're immutable. Box primitives. We can put byte arrays. Buffers. Again, not going to talk about buffers tonight. In short, they are kind of a smart byte array. So it's a sequence of 0 more bytes. You can write to it, you can read from it, and it expands automatically as necessary to accommodate any additional bytes. So it feels kind of like a vector or array list of bytes, if you will. If you actually use this, it's going to be copied as it's shared between verticals, so you never actually see the same instance. And then we have this last caveat here. Any implementers of shareable. This is how Vertex JSON objects are able to be placed into the map. What does shareable do? Nothing. It's a marker. It's a marker that carries the Java doc that says, if you slap this on a class, it must be thread safe. So, danger. If you're going to use this, put it on. Now, what about the class loader isolation problem? Well, as it turns out, if I implement a class and I put it on the system class path, then yes, it is available across all of the verticals. So if I have a custom class of my own that I want to implement, I need to do a couple of things. First of all, I need to make sure it's thread safe. Second of all, I need to make sure it implements shareable. And third, I need to get it on the system class path. So again, this is the -cp arguments that I'm pushing to the Java process on startup. So you do those 3 things, you can share your own custom classes between the verticals. So shared map. So I've got 2 verticals here, imagine that. In one vertical, I'm getting a map app.cache, if it doesn't exist, it's going to create that map and give me back the instance, and then I'm putting in the user ID 42. In another vertical, I get the map back out, and I get the value out of the cache. Shared set works similarly. Here we've got a set called app.sessions. We're going to put a session UUID in there, and then in the other vertical, I'm going to get the sessions out, loop through them, and do something useful with them. So this is kind of the extent of the shared data capabilities that we have today. So again, so between processes, we got a couple of good stories now. I can do message passing on the one hand, where that makes sense. I can do shared data on the other hand, where that makes sense. So both of these available to you out of the box in the framework, allowing you to do coordination between multiple processes very easily, much more easily than you would be able to do using Node. Which brings us to the last problem, the event loop. This is the one I said that we couldn't solve. At least we can't solve it in Node easily. So what is Node? Node is the implementation of the reactor pattern. What's the reactor pattern? Well, reactor pattern's got three main things. There's a paper out there that you can read that goes into a great level of detail, but at the end of the day, it's what? You've got an event loop. You have an application registering handlers with the event loop in some way. And then you've got events that happen that trigger those handlers. And this is how all of the programming takes place. Something happens, I listen to it, I do something with it, something else happens, I listen to it. You know, it's swing, it's any kind of UI programming, all different implementations of the reactor pattern. So this is what we carried into Node.js. So what do we know about the reactor pattern? Well, we've got, in Node, we have a single thread. We have a single event loop. Can't really do anything about this. Now, we can go hack V8. And there are actually projects out there that are hacking V8 to give you multiple threads in V8. If you want to do that, knock yourself out. I'd much rather go with a platform like the JVM that's kind of been working on this problem for several years and has gone to great lengths to get it right. And again, you want to go hack on V8, again, you're going at an even lower level of abstraction than you were before. What else do we know? Everything runs on it. You run code in Node.js, it's running on the event loop. You must not block the event loop. If you go out and calculate, Fibonacci 1000, you go out and start doing prime number identification, you go out and work with some legacy blocking API, do image processing, whatever it is, while that's going on, all those other requests that are coming into your process, they're waiting because there's only one thread, only one thing doing work at a time. So what are the problems with that kind of a programming model? Well, some work is just naturally blocking. Anytime you want to do intensive data crunching, you want to process genome sequence data, you want to process large graph networks, you want to process big data, all of these things, they take time, they take processor power. And so these things are going to block the event loop. We're not going to be able to deal with threads. Also, third-party blocking APIs. You want to talk to a database over JDBC, for example. Of course, you can't do that in Node, but similarly, it's a blocking API. JDBC assumes I'm going to send a SQL query, I'm going to get back a response, I'm going to do something with it. I'm going to send another query, I'm going to get something back, I'm going to wait. So anytime I've got I/O going on, anytime I've got network traffic going on, my processor is just sitting there and doing nothing. And it's also not doing anything, with the other requests that are sitting there waiting. So a pure reactor is just not a good fit for this kind of work. So if the type of application you're building is very amenable to the asynchronous non-blocking I/O problem, then Node is an awesome fit for you. You're in the sweet spot. If you have a lot of this type of work, Node is not a good fit for you. And people have gone crazy trying to make Node work for that kind of scenario because everybody said that they had to use Node, and they ended up hurting themselves. So, solution here, let's be pragmatic. Let's acknowledge that there are some types of work that want to execute on event loops. There are other types of work that don't. And so Vertex provides us with worker verticals. So worker verticals, they're not assigned a Vertex event loop thread. We're not going to put them on the event loop at all. Instead, we're going to manage a background pool of threads that we call background threads. And so I can flag any one of my verticals as a worker, and instead of it going into one of the event loop threads that equals my number of processors, it's going to go into that background thread pool. Just as with our regular verticals, workers never execute concurrently on multiple threads. So this gives us the same single-threaded programming model in the workers that we get with the normal verticals. However, not allowed to use the TCP or HTTP non-blocking APIs. So we communicate with verticals just like we do any other vertical using the event bus. You want to keep worker verticals to a minimum. Anytime you're using verticals, worker verticals, you're using them because you're doing something that's blocking. Well, if your entire application is worker verticals, and then you've got one non-worker vertical that just normal vertical that services requests and then passes them off to the blocking API, what have you done? You've just reinvented the old programming model with a new toy. So we want to keep these down. So now we've got this complete picture of Vertex's model of the reactor. This is what the Vertex team calls the multi-reactor. So we've got our event loop thread pool, we've got our background thread pool, we've got verticals assigned to the right positions, and then all the communication is accomplished with the event bus. So what does this look like? So I said something about Fibonacci earlier, so I've got this kind of toy example of a Fibonacci worker. What does a Fibonacci worker do? Well, it's going to get a hold of the event bus, register a handler at the fib request address, and when I get a message there, I'm going to calculate that Fibonacci number, and then I'm going to place the number that was requested in the result in a message and send that to the Fibonacci response address. Now in my what's called worker example, this is my normal vertical. Again, I'm getting the event bus. I've got a result handler here that is going to handle responses from the Fibonacci worker. And I'm going to register that handler at the Fibonacci response address. And then I have container. A container is another variable object that's available to you when you extend vertical. Container has a deploy worker vertical method. So when I do this, it's going to take that and place it off of the event loop and put it in that background thread pool. My arguments here are the address. I've got a configuration object that I can pass in different parameters. I can specify the number of instances of the vertical here. So if I put in 10 there, I would have 10 of these guys. And then I've got my handler that is just sending off the messages to the fib request. Okay, so let's go over the four again quickly, and then we'll do the fun little case study. So Node.js compels us to use JavaScript or something that we can compile down to JavaScript. Vertex, polyglot, good. Can use whatever language I want. Node.js inherently single-threaded. I can make this better, but I have to bolt a bunch of things on. I have to do a bunch of low-level glue code. Vertex leverages the JVM, already multi-threaded, makes it very easy for me to scale a single vertical across multiple threads. Node.js doesn't help us at all out of the box with inter-process communication. There are different options out there that we can leverage. You got to go bolt something in again from a third party. Maybe you do want to add that to your stack, maybe you don't. Or again, you can do some low-level programming. Vertex gives us this event bus out of the box. It recognizes this is something that we want to do. This is something that we're going to need to do. and allows us to communicate across those verticals on multiple threads, across verticals on multiple instances of the JVM, maybe distributed across many machines, and then also all the way down into the browser. So I've got a single communication model that is available to me everywhere my code is running. And then Node.js requires all the code to run on the event loop. If you've got blocking work, you're going to run into problems. Vertex gives us the background workers that allow that blocking work to be done off of the event loop. Now, there's a lot of other goodies in there. Stuff that, you can compose your applications with. We have a growing module repository. Multiple modules you can pull in to your own apps and then communicate with those over the event bus. So we've got you don't have to necessarily, all you want to do is serve up static resources, we've got a web server module. We have a Mongo persister that has been around for a while. JDBC is fairly new. We have the work queue that I've mentioned. Very simple authentication manager, probably not good enough for most of you. Works well for demos, but we need something better. Session Manager has just come out. We've got a socket.io implementation. Also, very nice detailed feature set. I didn't want to go spend my time walking through APIs with you. I know you guys can all go read. So I didn't want to read APIs back to you, but there's a whole list of things out there, several things that we didn't cover. Of course, we've got full WebSocket support. We've got the ability to do timers and do timed work with a scheduler. Of course, we mentioned buffers. We also have very good support for streaming and pumping of data between verticals. We can do routing of requests. And of course, we have a full-featured, non-blocking asynchronous file I/O API. These are all very well documented. One of the great things about Vertex is that, for the most part, it's very well documented. And if you do have problems, you know enough to go jump off into the source code and see how things are working and figure out what's going on. This is how I figured out most of the shared memory stuff. Okay, so I promised a case study. What is the case study? The case study is a Twitter clone called TwitX. It's using, of course, Vertex, Bootstrap, and then Knockout.js to do the event handling and binding in the browser. The code for this I pushed up this morning to GitHub, so you can pull it down and play with it. It's not quite ready for just out-of-the-box consumption. There's some manual legwork that has to be done in MongoDB. Over the next few days, I'm going to get that documented and also try to build the features into the app to make it will make that work go away. But just wanted to give you a heads up on that. But all the code that we're going to look at is, in fact, available. Ah, yes, the appeal to participation. Vertex is young. Vertex needs help. There's one guy working full-time on this. The rest of it is people like us spending our spare time doing stuff. So there is a Google group. It is fairly active. I probably get anywhere between 5 and 15 messages a day. A lot of it's, where's the framework going? How are we going to implement this? A lot of it's also, how do I do this? So it's kind of a merger of developers and users asking for help. Code's on GitHub. There's an IRC chat. I haven't done that before, but I know it exists. So what do we need? Well, we said you can program in any language that you want. If your language isn't there, we need you to implement a language handler for it. So those opportunities are there. Particularly, we're looking for folks who are interested in working on Clojure. Modules. We need more persistence modules. Right now we can do Mongo, we can do JDBC. There was a Redis one that we had for a while and then it died and now we're trying to resurrect that. But what if you want to do Couch? You want to do Datomic, some other store that I'm thinking about doing the Datomic one myself. But at any rate, we need that. Security is a big need. You want to do any kind of modern security, we just don't have that yet. And of course, we need people to talk about it. So we need examples, we need blogs, we need help with the documentation. All of these opportunities are there. You say, can I help with this? The answer is yes, every time. So need you guys to get involved. And that's all I have. One last thing that I ask of you. I have this talk up on SpeakerRate. I will be giving this talk several times. I appreciate your feedback. So if you take the time to go visit that URL and fill out an evaluation, tell me what you like about the talk, tell me what sucks about the talk, so that I can make it better for the next group of folks who get to sit through it. All the images were Creative Commons with the exception of a couple others that I had permission for, so I need to show you that. Okay, thank you guys for coming, I appreciate it.